ATX is a motherboard form factor specification developed by Intel in 1995 to improve on previous de facto standards like the AT form factor. It was the first major change in desktop computer enclosure, motherboard and power supply design in many years, improving standardization and interchangeability of parts. The specification defines the key mechanical dimensions, mounting point, I/O panel, power and connector interfaces between a computer case, a motherboard and a power supply. With the improvements it offered, including lower costs, ATX overtook AT completely as the default form factor for new systems within a few years. ATX addressed many of the AT form factor's annoyances that had frustrated system builders. Other standards for smaller boards usually keep the basic rear layout but reduce the size of the board and the number of expansion slots. In 2003, Intel announced the BTX standard, intended as a replacement for ATX. As of 2009, the ATX form factor remains a standard for do-it-yourselfers. BTX has however made inroads into pre-made systems. This was designed to solve the problems in BAT and LPX motherboards. The official specifications were released by Intel in 1995 and have been revised numerous times since. The most recent ATX motherboard specification is version 2.2. The most recent ATX 12V power supply unit specification is 2.31, released in February 2008. A full-size ATX board is 12AA, A9.6 in. This allows many ATX form factor chassis to accept microATX boards as well. Connectors. On the back of the computer case, some major changes were made to the AT standard. Originally AT-style cases had only a keyboard connector and expansion slots for add-on card backplates. Any other board interfaces had to be connected via flying leads to connectors which were mounted either on spaces provided by the case or brackets placed in unused expansion slot positions. ATX allowed each motherboard manufacturer to put these ports in a rectangular area on the back of the system with an arrangement they could define themselves, though a number of general patterns depending on what ports the motherboard offers have been followed by most manufacturers. Cases are usually fitted with a snap-out panel, also known as an I/O plate or I/O shield, in one of the common arrangements. If necessary, I/O plates can be replaced to suit a motherboard that is being fitted. The I/O plates are usually included with motherboards not designed for a particular computer. The computer will operate correctly without a plate fitted, although there will be open gaps in the case and the EMI/FI screening will be compromised. Panels were made that allowed fitting an AT motherboard in an ATX case. ATX also made the PS/2 style mini-DIN keyboard and mouse connectors ubiquitous. AT systems used a 5-pin DIN connector for the keyboard and were generally used with serial port mice. Many modern motherboards are phasing out the PS/2 style keyboard and mouse connectors in favor of the more modern universal serial bus. Other legacy connectors that are slowly being phased out of modern ATX motherboards include 25-pin parallel ports and 9-pin RS-232 serial ports. In their place onboard peripheral ports such as Ethernet, FireWire, eSATA, audio ports, video and extra USB ports. Variants. Several ATX-derived form factors have been specified that use the same power supply, mountings and basic back panel arrangement, but set different standards for the size of their board and number of expansion slots. Standard ATX provides 7 slots at 0.8 in spacing. The popular microATX size removes 2.4 inches and 3 slots, leaving 4. Here width refers to the distance along the external connector edge, while depth is from front to rear. Note each larger size inherits all previous colors area. Note, Open has conflated the term mini-ITX with a more recent 15AA, A15ACM form factor. Since references to mini-ITX have been removed from ATX specifications since the adoption of microATX, the open definition is the more contemporary term and the one listed above is apparently only of historical significance. Larger variants, a number of manufacturers have added 1, 2 or 3 additional expansion slots to the standard 12-inch ATX motherboard width. SSICEB Server System Infrastructure Forums Compact Electronics Bay Form Factor Measures 12AA, A10.5 in. eATX SSIEB, although true eATX is 12AA, A13 in. Most motherboard manufacturers also refer to motherboards with measurements 12AA, A10.1 in, 12AA, A10.4 in, 12AA, A10.5 in and 12AA, A10.7 in as eATX. While eATX and SSIEB share the same dimensions, the screw holes of the two standards do not all align, rendering them incompatible. eATX, Supermicro server motherboards measuring 13.68 AA, A13 in. UltraATX. In 2008, Fluxscorn unveiled a Fluxscorn F1 motherboard prototype, which is the same width as a standard ATX motherboard, but an extended 14.4 inches length to accommodate 10 slots. The firm called the new 14.4 AA, A9.60 in form factor for this motherboard UltraATX in its CES 2008 showing. Also unveiled during the January 2008 CES was the Lian Li Armor Suit PCP-80 case with 10 slots designed for the motherboard. XLATX. The name XLATX has been used by at least 3 companies in different ways. In September 2009, EVGA Corporation had already released a 13.5 AA, A10.3 in XLATX motherboard as its EVGA X58 classified 4-way SLI. In Q2/2010, Gigabyte launched another XLATX mainboard with model number GAX58AUD9 in 2010 at 13.6 AA, A10.3 in and GAX79UD7 in 2011 at 12.8 AA, A10.0 in. In April 2010, Gigabyte Technology announced its 12.8 AA, A9.60 in GA890FX AUD7 motherboard that allowed all 7 slots to be moved downward by 1 slot position. The added length could have allowed placement of up to 8 expansion slots, but the top slot position is vacant on this particular model. MSI released MSI X58 Big Bang in 2010, MSI P67 Big Bang Marshall in 2011, MSI X79 XPOWER Big Bang Do in 2012 and MSI Z87 XPOWER in 2013. All of them are 13.6 AA, A10.4 in. Although these boards have room for additional expansion slots, all 3 provide only 7 expansion connectors. The topmost positions are left vacant to provide more room for the CPU, chipset and associated cooling. Hptx. In 2010, EVGA Corporation released a new motherboard, the Super Record 2, or ESA2, whose size surpasses that of the EVGA X58 classified 4-way SLI. The new board is designed to accommodate 2 dual QPIL GA1366 socket CPUs, similar to that of the Intel Sculptrail motherboard that could accommodate 2 Intel Courier 2 quad processors and has a total of 7 PCIe slots and 12 DDR3 RAM slots. The new form factor is dubbed Hptx, and is 13.6 AA, A15 in. SSIMEB, server motherboards measuring 16.2 AA, A13 in. SWTX. Supermicro's SWTX form factor measuring from 16 AA, A13 in to 18 AA, A13 in. Most SWTX boards seem to be in the middle of this range around 16.48 AA, A13 in. WTX. Intel's discontinued WTX form factor measuring 14 AA, A16.75 in. Power supply. The ATX specification requires the power supply to produce 3 main outputs, plus 3.3 of E, plus 5 of E and plus 12 of E. Low power 12 of E and 5 of ESB supplies are also required. An A5 of E output was originally required because it was supplied on the ISA bus, but it became obsolete with the removal of the ISA bus in modern PCs and has been removed in later versions of the ATX standard. Originally, the motherboard was powered by one 20-pin connector. An ATX power supply provides a number of peripheral power connectors and 2 connectors for the motherboard, a 4-pin auxiliary connector providing additional power to the CPU, and a main 24-pin power supply connector, an extension of the original 20-pin version. 20-pin Molex 39-29-9202 at the motherboard. 20-pin Molex 39-01-2200 at the cable. 4 wires have special functions. PSON or power on is a signal from the motherboard to the power supply. When the line is connected to ground, the power supply turns on. It is internally pulled up to +5 V inside the power supply. PWROK or power good is an output from the power supply that indicates that its output has stabilized and is ready for use. It remains low for a brief time after the PSON signal is pulled low. +5 VSB or +5 V standby supplies power even when the rest of the supply lines are off. This can be used to power the circuitry that controls the power on signal. +3.3 V sense should be connected to the +3.3 V on the motherboard or its power connector. This connection allows for remote sensing of the voltage drop in the power supply wiring. Generally, supply voltages must be within a ±5% of their nominal values at all times. The little used negative supply voltages, however, have a ±10% tolerance. There is a specification for ripple in a 10HZ Euro 20 MHz bandwidth. The 20 to 24-pin Molex mini-FIT JR has a power rating of 600 volt, 8 ampere maximum per pin. As large server motherboards and 3D graphics cards have required progressively more and more power to operate, it has been necessary to revise and extend the standard beyond the original 20-pin connector, to allow more current using multiple additional pins in parallel. The low circuit voltage is the restriction on power flow through each connector pin. At the maximum rated voltage, a single mini-FIT JR pin would be capable of 4800 watts. Physical characteristics: ATX power supplies generally have the dimensions of 150 AA, A86 AA, A140 ohm and share a common mounting layout of 4 screws arranged on the black side of the unit. That last dimension, the 140 ohm depth, is frequently varied, with depths of 160, 180, 200 and 230 ohm used to accommodate higher power or modular connectors. Main changes from AT design: power switch. AT-style computer cases had a power button that was directly connected to the system computer power supply. The general configuration was a double-pole latching mains voltage switch with the 4 pins connected to wires from a 4-core cable. The wires were either soldered to the power button or blade receptacles were used. An ATX power supply is typically controlled by an electronic switch connected to the power button on the computer case and allows the computer to be turned off by the operating system. In addition, many ATX power supplies have an equivalent function manual switch on the back that also ensures no power is being sent to the components. When the switch on the power supply is turned off, however, the computer cannot be turned on with the front power button. Power connection to the motherboard. The power supply's connection to the motherboard was changed from the older AT standard. ATs had 2 similar connectors that could be accidentally interchanged by forcing the different keyed connectors into place, usually causing short circuits and irreversible damage to the motherboard. ATX used one large, keyed connector which could not be connected incorrectly. The new connector also provides a 3.3 volt source, removing the need for motherboards to derive this voltage from the 5V rail. Some motherboards, particularly those manufactured after the introduction of ATX but while AT equipment was still in use, supported both AT and ATX PSUs. If using an ATX PSU for purposes other than powering an ATX motherboard, power can be fully turned on by shorting the power on pin on the ATX connector to a black wire, which is what the power button on an ATX system does. At least the specified minimum load required by the PSU should be present. The standard does not specify operation without load and a conforming PSU may shut down, outputs incorrect voltages, or otherwise malfunction, but will not be hazardous or damaged. Airflow. The original ATX specification called for a power supply to be located near to the CPU with the power supply fan drawing and cooling air from outside the chassis and directing it onto the processor. It was thought that in this configuration, cooling of the processor would be achievable without the need of an active heatsink. 1. This recommendation was removed from later specifications. Modern ATX power supplies usually exhaust air from the case. ATX power supply revisions, original ATX, introduced in late 1995, defined three types of power connectors: 4-pin Molex connector, a Euro transferred directly from AT standard, plus 5 of E and plus 12 of E for PATA hard disks, CD-ROMs, 5.25-inch floppy drives and other peripherals. 4-pin Berg floppy connector, a Euro transferred directly from AT standard, plus 5 of E and plus 12 of E for 3.5-inch floppy drives and other peripherals. 20-pin Molex mini-ITX main motherboard connector, a Euro new to the ATX standard. A supplemental 6-pin O connector providing additional 3.3 of E and 5 of E supplies to the motherboard, if needed. This was used to power the CPU in motherboards with CPU voltage regulator modules which required 3.3 volt and or 5 volt rails and could not get enough power through the regular 20-pin header. The power distribution specification defined that most of the PSU's power should be provided on 5 E and 3.3 E rails, because most of the electronic components used 5 E or 3.3 E for power supply. The 12 E rail was only used by fans and motors of peripheral devices. Atx 12E1X, while designing the Penta-UMA 4 platform in 1999/2000, the standard 20-pin ATX power connector was found insufficient to meet increasing power line requirements. The standard was significantly revised into ATX 12E1.0. ATX 12E1X was also adopted by AMD Athlona XP and Athlona 64 systems. However, some early model Athlon XP and MP boards and later model lower-end motherboards do not have the 4-pin connector as described below. Numbering of the Atx revisions may be a little confusing. ATX refers to the form factor, and goes up to version 2.2 in 2004, while ATX 12E describes only the PSU. For instance, ATX 2.03 is pretty commonly seen on PSU from 2000 and 2001 and often include the P412E connector, even if the norm itself does not define it yet. ATX 12E 1.0. The main changes and additions in ATX 12E 1.0 were: increase the power on the 12 E rail. An extra 4-pin mini-ITX 12-volt connector to power the CPU. Formerly called the plus 12 E power connector, this is commonly referred to as the P4 connector because this was first needed to support the Pentium 4 processor. Before the Penta-UMA 4, processors were generally powered from the 5 E rail. Later processors operate at much lower voltages, typically around 1 E and some draw over 100 A. It is infeasible to provide power at such low voltages and high currents from a standard system power supply, so the Penta-UMA 4 established the practice of generating it with a DC to DC converter on the motherboard next to the processor, powered by the 4-pin 12 E connector. ATX 12E 1.1, this is a minor revision from August 2000. The power on the 3.3 E rail was slightly increased and other smaller changes were made. ATX 12E 1.2, a relatively minor revision from January 2002. The only significant change was that the A5 E rail was no longer required. This voltage was required by the ISA bus, which was no longer present on most contemporary computers of the time. ATX 12E 1.3, introduced in April 2003. This standard introduced some changes, mostly minor. Some of them are: slightly increased the power on 12 E rail. Defined minimal required PSU efficiencies for light and normal load. Defined acoustic levels. Introduction of serial ATA power connector. Guidance for the A5 E rail was removed. ATX 12V2X, ATX 12V2X brought a very significant design change regarding power distribution. On analyzing the then current PC architecture's power demands, it was determined that it would be much cheaper and more practical to power most PC components from 12 E rails, instead of from 3.3 E and 5 E rails. ATX 12V 2.0. The above conclusion was incorporated in ATX 12V 2.0, which defined quite different power distribution from ATX 12V1X. Most power is now provided on 12V rails. The standard specifies that two independent 12V rails with independent overcurrent protection are needed to meet the power requirements safely. The power on 3.3V and 5V rails was significantly reduced. The main ATX power connector was extended to 24 pins. The extra 4 pins provide one additional 3.3V, 5V and 12V circuit. The 6-pin O connector from ATX 12V1X was removed because the extra 3.3V and 5V circuits which it provided are now incorporated in the 24-pin main connector. The power supply is required to include a serial ATA power cable. Many other specification changes and additions, ATX 12VV 2.01, this is a minor revision from June 2004. An errant reference for the A5V rail was removed. Other minor changes were introduced. ATX 12VV 2.1, this is a minor revision from March 2005. The power was slightly increased on all rails. Efficiency requirements changed. ATX 12VV 2.2, another minor revision. Specified high current series wire terminals for 24-pin main and 4-pin plus 12V power connectors. ATX 12VV 2.3, effective March 2007. Recommended efficiency was increased to 80% and the 12V minimum load requirement was lowered. Higher efficiency generally results in less power consumption and the 80% recommendation brings supplies in line with new Energy Star 4.0 mandates. The reduced load requirement allows compatibility with processes that draw very little power during startup. The absolute overcurrent limit of 240 VA per rail was removed, allowing 12 V lines to provide more than 20 A per rail. ATX 12VV 2.31, this revision became effective on February 2008. It added a maximum allowed ripple noise specification of 400 mV to the PWRON and PWROK signals, requires that the DC power must hold for more than 1 millisecond after the PWROK signal drops, clarified country-specific input line harmonic content and electromagnetic compatibility requirements, added a section about climate savers, updated recommended power supply configuration charts, and updated the cross-regulation graphs. ATX 12VV 2.32, ATX 12VV 2.4, ATX Power Supply Derivatives, SFX. SFX is merely a form factor for a power supply casing and the power specifications are almost identical. Thus, an SFX power supply is mostly interchangeable with the ATX power supply. The only difference is that the SFX specifications do not require the A5V rail. Since a 5V is required only by some ISA bus expansion cards, this is not an issue with modern hardware and decreases production's costs. As a result, ATX Pin 20, which carried a 5V, is absent in current power supplies. It was optional in ATX and ATX 12V version 1.2 and deleted as of version 1.3. SFX has dimensions of 100A, 125A, 63.5 ohm with 60 ohm fan compared to standard ATX of 150A, 86A, 140. Optional 80 or 40 ohm fan replacement increases or decreases the height of the unit. Some manufacturers and retailers incorrectly market SFX power supplies as a microATX or microATX power supplies. TFX, another small form factor power supply with standard ATX specification connectors. Generally 5.75A, 3.25A, 2.5A and A. Hptx provides a Hptx-style motherboard connector which is incompatible with the standard ATX motherboard connector. AMD-GES, this is an ATX 12V power supply derivative made by AMD to power its Athlon MP platform. It was used only on high-end Athlon MP motherboards. It has a special 8-pin supplemental connector for motherboard, so an AMD GES PSU is required for such motherboards PSUs. EPS-12V EPS-12V is defined in SSI and used primarily by SMP multi-core systems such as Core 2, Core i7, Opteron and Xeon. It has a 24-pin main connector, an 8-pin secondary connector and an optional 4-pin tertiary connector. Rather than include the extra cable, many power supply makers implement the 8-pin connector as two combinable 4-pin connectors to ensure backwards compatibility with ATX-12V motherboards. Recent specification changes and additions, high-performance video card power demands dramatically increased during the 2000s and some high-end graphics cards have power demands that exceed AGP or PCIe slot capabilities. For these cards, supplementary power was delivered through a standard 4-pin peripheral or floppy power connector. Mid-range and high-end PCIe graphics cards manufactured after 2004 typically use a standard 6 or 8-pin PCIe power connector directly from the PSU. Interchanging PSUs. Although the ATX power supply specifications are mostly vertically compatible in both ways, there are potential issues with mixing old motherboard systems with new PSUs and vice versa. The main issues to consider are the following: the power allocation between 3.3V, 5V and 12V rails are very different between older and newer ATX PSU designs, as well as between older and newer PC system designs. Older PSUs may not have connectors which are required for newer PC systems to properly operate. Newer systems generally have higher power requirements than older systems. This is a practical guidance what to mix and what not to mix. Older systems were designed to draw most power from 5V and 3.3V rails. Because of the DC-DC converters on the motherboard that convert 12V to the low voltages required by the Intel Pentium 4 and AMD Athlon XP processors, such systems draw most of their power from the 12V rail. Original ATX PSUs have power distribution designed for pre-P4/XP PCs. They lack the supplemental 4-pin 12-volt CPU power connector, so they most likely cannot be used with P4/XP or newer motherboards. Adapters do exist but power drain on the 12V rail must be checked very carefully. There is a chance it can work without connecting the 4-pin 12V connector, but caution is advised. ATX-12V1X PSUs have power distribution designed for P4/XP PCs, but they are also greatly suitable for older PCs, since they give plenty of power both on 12V and on 5V/3.3V. It is not recommended to use ATX-12V1X PSUs on ATX-12V2X motherboards because those systems require much more power on 12V and much less on 3.3V/5V than ATX-12V1X PSUs provide. ATX-12V2X PSUs have power distribution designed for late P4/XP PCs and for Athlon 64 and Core Duo PCs. They can be used with earlier P4/XP PCs, but the power distribution will be significantly suboptimal, so a more powerful ATX-12V 2.0 PSU should be used to compensate for that discrepancy. ATX-12V2X PSUs can also be used with pre-P4/XP systems, but the power distribution will be greatly suboptimal, so this is not recommended. Systems that use an ISA bus should have a PSU that provides the A5V rail, which became optional in ATX-12V 1.2 and was subsequently phased out by manufacturers. Not all computers use standard, interchangeable ATX power supplies. In particular, some proprietary brand name systems require a matching proprietary power supply. See also, Hptx, computer form factor, mini-ITX, power supply rail, power supply unit, SSICEB, references. External links, ATX board specifications, ATX motherboard specification, V2.2, ATX riser card specification, V1.0, ATX power supply specifications, ATX-12V power supply design guide, V2.01, ATX-12V power supply design guide, V2.2, power supply design guide for desktop platform form factors, V1.1. Power Supply Design Guide for Desktop Platform Form Factors, v1.2, EPS Power Supply Specifications, EPS 12V Power Supply Design Guide, v2.0, EPS 12V Power Supply Design Guide, v2.91. EPS 12V Power Supply Design Guide v2.92, Other, Power Supply Form Factors, Various Power Supply Cables and Connectors, A Short History of Power Supply Voltage Rails, ATX Power Supply Connectors with Pinouts, More ATX Power Supply Connectors with Pinouts, ATX Power Supply Terminology.